In today's session, primarily aimed at Metadata Driven UI, we would cover how to configure routes for a single page application. We shall also learn defining navigation links, imperative routing, and passing data across routes. We will discuss and understand various UI framework models, their features and usage to generate the desired UI form with validations. Finally, we will learn how to internationalize the application, including labels, error messages, and static text. Before we start, just a brief about the project and directory structure. I have cloned OE sample project from the Git URL that you can see on my screen. The directory contains several folders and files. Bower is used for managing client-side dependencies, and all the UI code is inside the client folder. The client folder primarily has an index file along with elements, templates, and few other folders. Templates folder has the templates file that act as a skeleton for our forms. Your application directory structure could be different, and it entirely depends on application requirement and complexity. Let's get started and run our application using npm run startup command. You can see that the application is available at localhost 3000. Let's navigate to it and log in as John with the password as John. Application has a top header, side menu, and the content area. However, there is nothing visible on the home page. We will get things in shape in a while, but before that, let's quickly scan through the index page and see what's in there. As you can see, it has few imports, styles, and script section, but most importantly, the body has a single component called OE app. This is, in a way, the entry point to the application. OE app is a Polymer component defined in oeapp.html that has the DOM module, some local styles, and the template markup. Important components to note here are OE message handler that manages and shows all application level notifications and toasts. OE app uses Polymer's app layout components to achieve its overall skeleton. OE side nav is a side navigation bar that we have placed inside the tower. We will define the navigation links in a while, and those will appear here. Notice the group name attribute that we have set to app group. This allows us to group navigation links together, and we can place different constructs to show different set of navigation links. And finally, OE app route, which manages client-side single-page application routing. We have configured it to pull the routes from API/UI routes REST endpoint. Depending on the browser's location, the OE app route component finds a matching route definition and renders it. So let's explore what goes in a route definition. UI route framework model allows configuring client-side SPA routes and has 4 primary properties. Type property, which could have a value of page or element, specifies whether the route is rendering a partial HTML or a web component. Name is just a friendly name to identify the route. Path is expressed like URL pattern. The OE app route component matches this property with browser's location to decide which route to render. Finally, import property defines URL to pull the rendered data, which could be an HTML partial for page routes or a web component definition in case of element routes. Notice that import could also have path parameters which are replaced dynamically depending on actual value of browser's location. The client-side component OE app route drives the SPA routing. Navigation link framework model allows configuring the links. These links can then be shown in a side nav bar, a toolbar, or in a bottom panel. A navigation link has a friendly name to identify with, has a URL obviously, a label, and an icon. Top-level flag decides if it is a top-level link to handle multi-level nested links. Parent is the name of the parent link, used again for handling nested links, and the group. Notice that the link can be placed in application in numerous ways without any limitation. It could be a side navbar or a toolbar menu or a bottom panel. A flat bottom panel may choose to ignore the top level and parent properties. In this example, we are using OE side nav component. The sample application has two predefined users. John has a user role user and admin has a user role of admin. Let me log in through another window using admin. And yay, we see some pre-created navigation links for admin user to manage UI configuration data. The application, index page, and site nav are all same, but the data personalization scope on navigation links ensure that these links are only visible to admin user. Click on Route link and we see a list of existing UI routes. Notice the browser location and path pattern of middle row. As we discussed, OE app router matched the middle route to the URL pattern, pulled the element definition from API UI component/UI route list and placed it in work area. We only have default list HTML as template, and rest of it, including column configuration, is automatically generated. Click on the plus icon on top right and a form appears for capturing UI route data. Again, this is auto-generated based on the template. In a while, we will see more of it and understand it in detail. But for now, let's configure a UI route to display a dashboard page when John logs in. Enter type as page as we are loading an HTML partial. Give a friendly name dashboard. We want to load the dashboard by default, so I give slash as the path and src/dashboard.html as import property. We want to make sure only John sees the dashboard by default and not the admin, so we also limit the scope to roles in user. Click on save and the auto-generate save functionality saves the record to server. Now when John logs in, he sees the dashboard by default. The dashboard HTML file is just an HTML partial that houses nicely arranged remittance summary and OE chart elements. Chart loads the data from remittance data.json file. Let's now see how we can load a web component on a route. This time we define an element type route on /viewProfilePath to import and load the user profile web component from src/userProfileHTML. We also skip the scope since we want all users to be able to view profile. Let's now create a navigation link so that our users can access this URL. Similar to UI routes, you can see list of navigation links. These are pre-created for admin scope. Click on plus icon and you see an auto-generated form for navigation links. We define a navigation link that navigates browser to /viewProfile, where OE app router will take over to load and display the user profile component. Provide a label, icon, and make sure the group is app group, as the OE side nav component will load only the links in this group. No scope, as we want all users to see this link. Our users can see the profile link now, and clicking on it loads and shows the user profile. As you can see that userprofile.html is web component. To go back to the dashboard, John has to click browser back button. It would be nice to provide a link. Let's create another navigation link, but scope it only for user role and not for admin. We can see that the link is not available for admin user, but John, who has user role, can see the dashboard link. We have already seen UI route and navigation link forms that were auto-generated based on metadata. Let us see this in some details and understand how we can create and control the auto-generated forms for business models. For a simple data capture form, the underlying model definition has enough data to generate a simple form. The framework takes this definition data and mixes with the template to generate the form. Templates provide the skeleton, button placement, and pre-configured behaviors that bring life to the component. Often, we want more than simple auto-generated forms. To do this, we need some additional metadata. This can be defined in oecloud framework model UI component, which allows configuring the templates to use, fields, their type and location, and any custom validations that we want. UI element and type mapping provide means for form-specific or global overrides respectively. To understand this, let's first see how some of our functional models look like and how they relate to each other. City model is a simple reference code with a city code and description. Both are derived from base model, but we have defined code property to override certain behavior. A city belongs to a province. Province model again has a code and description. It belongs to a country and has many cities. Our country model has many provinces. It also has a zip pattern field which we will use to perform some client-side validations on zip code field. Address model has some of the common address fields. Notice that line 1 is made as mandatory field, but line 2 is not mandatory. City, province and country fields store their respective codes as string, hence the type is equal to string. And ref code type is specified as respective ref code models. Gender model, derived from enum base, again inherits code and description fields, and we have provided the enum list fixed values. Certification model has just the certification name and marks obtained. Finally, the user profile data that we saw under the profile link is stored in user info composite model that refers to some of the earlier defined models. It has first name and last name as string fields, date of birth as date type, gender field with type as string but enum type as gender, phone and email are stored as string and have a pattern validation, skills is an array of strings, and address is an embedded object of type address. Lastly, we have an embed many relationship to certification model. Obviously, the profile details belong to an app user. Let's quickly add some auto-generated UI for capturing these data, and then we will tweak things to our requirements. As we saw, we already have a UI route for /view/model-template path, which we used in UI for routes and navigation links. All we need is some navigation links to allow user to navigate easily. Suppose we want city form to appear directly rather than a list. We give URL as /view/city-form. The route will pull the form template rather than the list template. We also use top level as true for main link and set top level as false for our child links and specify the parent to achieve the hierarchy. We will restrict these links to only admin role. We define province link to show province list by default. We see that the links are not available to John but only to admin since we provided the scope restriction to admin role. Navigate to province list and add a new province for West Bengal. Notice how the auto-generated form for province has a country dropdown, allowing us to select the country to which the province belongs. Navigate to city form and add a new city Kolkata. Again, since the city belongs to province, we automatically get a list of provinces to select from. Let's type the URL for address form manually in the browser. We get input box for line 1, which is mandatory, line 2 followed by city, province and country fields, which are all pre-populated drop-downs. Note that the drop-downs show all the values always. We would like the province to filter by selected country and cities to filter by selected province. We may also want to change the order of the fields. To achieve this, we need to define additional metadata in the framework model UI component. We already have some pre-configured metadata for UI route, UI component and navigation link forms. Let us create a new one for address form. A UI component has a name, which is address form in our case, the template to use for rendering the form. For now, we will use default form template. Our underlying model is address. We put fields property as array of string fields in the order that we want in our form. Let's put country field before other fields and save. If we refresh the page, we see that the field order changes on screen. Notice that since we used default form template, we also get the save and other menu buttons. But suppose we don't want to directly save address, but we intend to capture address as part of another form. Only fields are required and we don't need save delete buttons and its corresponding functionality. Let's use another form template, nosaveform.html. Notice that we have removed the save buttons and changed behaviors to remove the model save handling. We will also change the fields array and see some more usage effect. In the fields array, we now have a mix of JavaScript objects and strings. When specified as JavaScript object, we specify field name under the field ID property. Container equal to sec1 property forces the field to be created in a separate div with ID equal to sec1. The default name for the container is fields. We can add any other additional random property that we want to set on the control. Here we are binding to selected item property of dropdown to extract it into selected country variable. We want to change label for line 2 as locality. We also want line 2 to be mandatory when country is India and disable it when country is UK. Note, the property in expression is same as our model property where we are capturing country. Finally, the zip code field has to have a pattern validation, but the pattern is not fixed and should be used from selected country's zip pattern property. Save the metadata and refresh the address form. We see that save button disappears. Country field now goes in separate div. Line 2 label has changed. Also, line 2 becomes mandatory when country is India. Line 2 becomes disabled when country is UK. Zip code field's pattern validation changes depending on which country is selected. Our address form still shows all provinces irrespective of selected country, and also the city drop-down shows all cities irrespective of selected province. This is because by default these drop-downs simply list entire data in underlying model. Any attribute set in fields array overrides the default derived from model definition. UI element framework model allows next level of overrides where a particular field on a particular form can be overridden to behave differently. Let's override list URL for province to show filtered provinces for the selected country. Similarly, city list to be filtered based on the selected province. Refresh the page and you can now see the province list filtering for selected country and cities filtering for selected province. Note that we can also specify list URL attribute with province and city fields in our UI component fields array directly. Doing it in UI element allows scope-specific overrides by virtue of data personalization. Now let's turn our attention to slightly more complex forms. User's profile is stored in user info model. It has first name, last name as string type fields. Date of birth is date type field. Gender, which is string type, with underlying enum type as gender. Phone, email, which are self-explanatory. We have skills field, which holds array of strings. Address is a composite embedded field of address type. User info model embeds many user certifications. Let's see how the auto-generated form looks like by navigating to /view/userinfo-form manually. Date of birth is rendered as date input. Address field appears automatically. The composite fields for address can be referred in UI component fields array using dot notation. Let's define the UI component entry for our user info form. We stick to default form template and exclude user ID and app user ID fields from our form, which we don't want user to enter. In fields array, we specify address.country to appear first, followed by address.province, and label the field as state. Notice that the field entry as string and object is still possible for composite fields as well. We will only specify two fields, and rest all we want to appear in form automatically. Auto inject fields flag does this for us. Refreshing the page reflects the changes, and country and province fields are now shown up. This reveals an interesting fact that the composite fields for address model are all rendered as singular disjoint fields, cobbled and placed together, and is not using our address form we defined earlier. You can see it in Chrome Inspect Elements. This is the default behavior to extend child fields, extract their validations, and add as individual fields in form. Let's now configure the user info form to use our address form directly to render the address compound field. Other than the field order, containers, and labels, we introduce two important concepts here. First, we use the value attribute on email field and specify it to be a combination of first name and last name fields. And second, address field has UI type as address-form, which means instead of expanding and rendering loose fields for address models, render the address field using address form component. Refresh the page and we see that field order and other changes are reflected. Email field is auto-calculated based on first name and last name, but none of the address fields are visible. Chrome Inspect reveals that address form component is added but not visible. This is because we need to import the address form explicitly. We add the import in oecloud.html. Notice that the import is an API URL rather than a static HTML. Now we see that address form appears along with all the layout and filtering behavior that we implemented earlier. By default, the date input control shows the date in DD, MMM, YYYY format. As you would expect, we can override it by providing format attribute to the date of birth field. While this is fine, but generally the date format is uniform application wide, and we would want to override the format across all forms and all date controls. Framework model type mapping comes in handy, which maps loopback model type to UI control and its additional attributes. Let's revert the format from date of birth field and define a new type mapping entry that globally maps date data type to display OE date control with format mm-dd-yyyy. This can also be used to globally style the controls by providing class attribute. Our gender field is shown as combo box, but let's say we want it to be rendered as radio buttons. We post UI element entry for gender field and change the UI type to OE radio group instead of default dropdown. We can use another template, userinfo tabs-form.html, which houses next and previous buttons for navigation with some JavaScript logic to handle them. But more importantly, it has its fields container inside an Iron Pages component. Update the UI component record for userinfo form to use the tabular layout and we can see our profile edit page looks dramatically different. The problem, however, is user can click next without entering mandatory fields and would know of any errors only on last step. We cannot validate entire form on each next click, as that would mean fields on step 2 will also show error when user presses next on first step. We need some way of validating fields block by block. OE block validator component allows grouping set of fields that need to be validated together without affecting other fields on the form. We wrap our container into OE block validator elements, and the next click handler would make sure not to move forward if fields in current blocks are not valid. Now the next click stays on current section unless all the fields in this section are valid. Our form is much better now, but there are still some issues. Currently, by default, userinfo model form would interact at /API/userinfo's endpoint. Generally, this endpoint would be disabled since we don't want arbitrary user info to be created. Our end users should always be able to load and edit only their own profile and nothing else. As we provided model name as userinfo on the UI component entry, the REST URL is automatically derived from model. We do not want to allow random user profile creation via /API/userinfos, as this URL would normally be protected. We can access our profile information via /API/appusers/me/profile URL. We will use this URL for our profile form. Normally, the model handler appends record ID to the REST URL for fetching the record. In this case, since the URL is singular, we don't want record ID to be appended in CRUD REST URLs. The trick to stop model handler from appending the ID in the end is to terminate REST URL with a $. Our user info form still does not fetch the data. It needs a trigger for fetching the data, and the trigger is to set model ID on it. Let's get into Chrome debugger and trigger this. See how data is pulled by form when model ID is set. So to show edit profile view to user, we need to open the form and simultaneously set model ID onto it. There are two ways to achieve this. One, pass model ID via URL parameter. All the URL parameters are set onto the target element that is rendered by OE app route. And second, imperatively navigate to new path and pass the model ID. As you will see in imperative navigation, additional parameters are set onto the target element. Let us add menu in application to open edit profile page. This would be a simple href navigation. Notice our menu text is wrapped inside an I89 MSG component. This allows us to internationalize the text. We also define a UI route, and as you can see in path property of UI route, we pass the model ID to the new form via URL parameter. Refresh the page and click on Edit Profile link. You will see that data fetch is triggered and profile data is loaded. Now let's see how to trigger an imperative navigation. We add another Edit Profile menu, but this time instead of providing an href, we add an on-tap event handler. The event handler simply calls OE navigate to function that takes first argument of URL and an optional second argument of data to be passed for next route. In this case, we are saying navigate to /edit my profile route and set model ID to me on whatever element app router decides to render. Let us create a UI route that renders user info form on edit my profile route. Note that there are no URL placeholders this time. Clicking on the menu navigates to /edit my profile page and simultaneously also fetches the data. Note, however, the difference between two approaches. If user refreshes the browser by pressing F5, data won't be fetched in second approach. However, the approach is still useful when the data is available on client side and we don't want to fetch entire data again. We can just pass the entire target data as a second argument to OE navigate to function. We know that model handler holds and maintains data in our user info form in a variable called user info. We can pass this entire object as second argument. Let's see this in action. Let us pick the user profile data from session storage and pass this as second argument. Notice that this time we don't see the data loaded toast. We still have one final thing to go in our form. Once profile data is saved, our application remains on the form and does not navigate away to another page. You would have noticed the transitions array property in route definition that we left blank so far. Each transition defines event, route, and optionally map properties. If the element rendered by current route raises the event specified in transition, the OE app router would transition the application to the route specified by route property in given transition. The event's details are passed as additional data for route, similar to the second argument in OE navigate to function. Sometimes the event detail object keys do not match the variable name required on target element. You can use the map property. In our case, when form raises OE form data updated event, we transition to /view profile route. The event detail that has profile data under data key should be set on user property of target element. So we specify the map. Note that you can use placeholders in transition route which are replaced using event detail object properties. With transitions specified, when user updates the profile, application is automatically redirected to the view profile page. This, combined with data personalization, creates a configurable, flexible, and yet powerful application navigation. We could create two edit profile route, one scope to admin users and other to business users, each one having different transitions. Say admin users are redirected to dashboard, while all other users are redirected to view profile. All this using configuration and no coding. The literal model in oecloud framework allows defining translation for labels, text, and error messages. Primary properties in literal model are translation key and translation value. Let us define the literal data, this time through API Explorer, since we need to define several records. To define French literals, we have added scope as language French. First four records translate form labels, which is straightforward. Translation for value missing error code is interesting though. Notice the $label placeholder. Actual value of label from the component replaces the placeholder and error is displayed accordingly. Finally, record updated is the message code for showing save success message. We define our translation for this. Let's upload the records and refresh the page. Changing the language through language picker, we see that labels update instantly in profile form. Note also that since all OE controls are I89 enabled, the French labels reflect in other pages also. Error messages are shown in French, and as you can see, the label placeholder also work as expected. Including the save success message.